This investigation is called paper chromatography, and the experiment is to investigate the composition of inks using paper chromatography. So we use chromatography as a separation technique to find out the different colours that a particular ink is made from. To set up the chromatography, we start with a piece of plain chromatography paper, and what we need to do is we need to draw a pencil line along the bottom of the paper, and the pencil line is where we're going to add the ink. We use pencil because pencil is insoluble in water, because we're using water in this experiment, so it's not affected at all by the water. So I've added my pencil line, and you can see that I've put my first ink that I'm testing, and I've put a concentrated drop of that onto my pencil line, and then I'm going to add along the pencil line the rest of the inks that I am testing. So I've done my paper, so now you can see all of my different inks along the bottom of my chromatography paper on the pencil line. I have attached my paper to a wooden splint so that I can hang it into the beaker. So I'm going to add my paper to my beaker, and when I hang it onto my beaker, I need to make sure that the bottom of my paper is touching the solvent, the liquid part, and I need to make sure that the liquid is below the level of my pencil. And as you can see, the water is now starting to rise up the paper, and as it rises up, once it meets the ink will dissolve in the liquid, in the solvent, and will be carried up the paper. Now in this instance we're using water as the solvent, but if I were using something like permanent pens or permanent ink, then my solvent wouldn't be water, I would actually use alcohol or a different type of solvent. The chromatography has been running for a while, so I'm going to remove my paper from the solvent, and these are my results. Now you're not likely to be given results like these in an exam. They will give you some that look more like this. So if we look at what's happened here, we've got sample X, so this is an unknown ink. We have ink A, ink B, and ink C. We can see that ink A is orange, ink B contains only red ink, and ink C contains only blue ink. Ink X, which is our unknown, is made of two different inks, and we can see that it is a mixture of ink C and of ink B. The other thing that they can ask you to do once you've completed a chromatography is to calculate the RF value for one of the pieces of ink on your chromatography paper. So I've looked at this blue dot of ink that was in sample X. So there are two measurements you have to take. The first measurement is the distance from the pencil line to the solvent front. So that's where your solvent has risen to on the paper. So I've measured that distance, and it's 10 centimeters. The second measurement is the distance that the ink has moved. So here, my ink has moved 3 centimeters. So my RF value is the distance that my ink has moved, 3, divided by the distance that the solvent moved, 10. So 3 divided by 10, which gives me a value of 0.3.